Hello everyone! This video would focus on determining the proportionality constant K and the equation of a given table, which is an example of an inverse variation. Before we go further, please feel free to check out the description below for the link of the other series of topics related to inverse variation. Before we jump into this example that we have right here, let's have a review on the basics of inverse variation. So what is inverse variation? To better understand this type of variation, let's look at variable A and variable B. For inverse variation, if variable A increases, variable B will decrease. Now notice the direction of the arrow. The other one goes up while the other variable goes down. On the other hand, if variable A decreases, then variable B will increase. And again, notice the direction of the arrow. The direction of the arrow goes in opposite direction. And that is what we mean by inverse variation. So whenever we see two variables are inversely proportional with each other, we can say that A varies inversely as B, or A is inversely proportional to B. Now let's look at some real-life examples of inverse variation. Speed and time are inversely proportional to each other, which means that if a car moves at a faster speed, then it takes less time to get to its destination. On the other hand, if a car moves at a slower speed, then it takes more time to get to the same destination. And that makes speed and time inversely proportional to each other. Now let's look at another example. Number of trees and air pollution on a given area are inversely proportional to each other, which means that if the area has a greater number of trees, or if it has more trees, then it has less pollution. On the other hand, if that same area has less number of trees, then it will have a more probability of getting air pollution. And so again, these two are inversely proportional to each other. Now let's look at another example. Practice and number of mistakes are inversely proportional to each other, which means that the more we practice, the less mistakes we commit. On the other hand, the less we practice, the more mistakes, or we get more probability of committing mistakes if we have less practice. So these two are inversely proportional to each other. We also remember that the general equation for an inverse variation is y equals k over x, where our k is called the proportionality constant. So that we can go ahead and say that if we wanted to determine the constant of variation, or the proportionality constant k for an inverse variation, we go ahead and we can rearrange this equation as k equals xy. Okay, going back to the example right here, this table is an example of an inverse variation. Determine the proportionality constant, which is the k, and the equation that would work for this table. So in this example, we are supposed to first determine the value of k. Remember that k, which is the proportionality constant for an inverse variation, is the product between x and y. So I go ahead and multiply x and y here. So these x and y shall be multiplied together. So that would be 1 times 8, and that would be 8. And then that's going to be 2 times 4, that would be 8. That means that for all of these, the product would be 8, since, again, this is an example of an inverse variation. But I'm going to go ahead and show the work down here. Okay, so our constant of variation, which is k, represented as k, is 8. You can only solve for 1 here. That should be fine because it already says that it is an inverse variation. But I just wanted to show to you that for an inverse variation, all of the products of k, or all the products of x and y, would be the same for all of these columns, which is 8. Now, we also remember that the general formula for an inverse variation is y equals k over x. So to determine the equation for this table, we go ahead and plug this 8 into the k, so that the final equation that we're going to have here would be y equals 8 over x. And this is the equation for this table that we have up here. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. In order that we can determine the proportionality constant k, we write the equation down here that is k is equal to the product of x and y. So we have to multiply x and y. That is our proportionality constant k. We can multiply just one row here. 1 times 2, that means our k is 2. But then I'm going to go ahead and show to you that the k for each of this row would be the same, which is 2. So I'm going to go ahead and show the work down here. Okay, our value here is 2, which is the same for each row. Again, you don't have to show all of this work here, since it says at the beginning here that this given table is an example of an inverse variation already. So you can just go ahead and use one row here, and that should be good. But I just want to show to you that it's going to be the same for each row, no matter which row you would use to solve for k. So that we go ahead and remember that the general equation for inverse variation is k over x. So we go ahead and plug this 2 into the k, which is our constant of variation as we solved it from the table. Our final equation then for this table that we have here would be y equals 2 over x. And this is again the equation for this table up here. Did you get the same answers as this? Good. Perfect. Now let's move on to the next example. Okay, so let's go over this example right here. So we first determine the proportionality constant k. So that would be k is equal to the product of x and y. So in this case right here, I have 1 times 1/2. So the value here is 1/2. And I will show the rest of these. Again, although we can use this already as the value for k, I just want to make sure that I show to you that no matter which of these columns we use, the answer would still be the same. So I'm going to go ahead and show the work down here. Okay, we have shown that the k value would be the same for each row, and that is the proportionality constant k is equal to 1/2. The general equation for inverse variation is y equals k over x. So we go ahead and plug this 1/2 into the k value. So this comes out y equals 1/2 over x. Since this is a complex fraction, we can go ahead and simplify this further. We are supposed to get the reciprocal of the denominator, which is 1 over x. Because again, remember, there is an invisible denominator of 1, and we multiply it. So this would be equal to 1/2 times, flip this or get the reciprocal of this, that would be 1 over x. Again, so what I did here, since this is an example of a complex fraction, I write the 1/2 and I will multiply the reciprocal of the denominator. That would be 1 over x. This tells us that the product for this would be 1 over 2x. So then we can go ahead and rewrite this equation as y equals 1 over 2x. And this is the equation for this table that we have up here. Although we can go ahead and just keep it as y equals 1/2 over x. You can also have that. That is also correct. But this is a more simplified one without having to deal with a complex fraction. Or sometimes others would write this as y equals 0.5, because that's 1/2 over x. That should be fine too. So any of these three answers here would be correct. Y equals 1/2 over x, y equals 1 over 2x, or y equals 0.5 over x. That's it. If you found this video helpful, hit like and subscribe for more math videos. See ya!